You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore the structure and organization of relational databases by breaking down their key components. We will focus on tables, fields, records, and keys, the foundational building blocks of how data is organized in relational systems. These terms are essential to understanding how modern databases work and how information is linked together. Our goal is to explain these elements clearly and align each with the vocabulary and concepts tested in Domain 5 of the Information Technology Fundamentals Plus exam. The exam may ask you to define these components or recognize them within a scenario. For example, a question might describe a table of customer records or ask what type of key ensures uniqueness. You are not required to design a database, create schemas, or write queries. Instead, you need to understand the structure of relational databases and be able to identify and explain their parts. Knowing what each element does and how they work together will help you succeed on the exam and build foundational knowledge for future IT learning. A table in a relational database is a structured collection of data arranged in rows and columns. Each table is designed to store information about a specific subject or entity. For example, a customer's table might store names, addresses, and contact details. An orders table would contain order numbers, dates, and purchase totals. A products table could list product names, prices, and inventory counts. Each table is isolated by topic to help maintain organization and avoid redundancy. Fields, also known as columns, represent individual categories of data within a table. Each column has a name and a data type that defines what kind of information it holds. For example, a column might be named first name and contain text values, or phone number and contain formatted numeric values. Other common field types include dates, currency amounts, and Boolean values that represent true or false. Each field holds just one type of data to keep the structure consistent and searchable. A record, also known as a row, is a complete set of related data about a single item or entity. In a customer's table, one row might contain all the information about a single customer: their name, customer ID, address, and contact number. Each field in the row corresponds to one column in the table, and every row contains one value per field. The record brings together related details into a single entry and makes it easy to retrieve and review that data as a unit. The primary key is one of the most important elements in a relational table. A primary key is a field that uniquely identifies each record in the table. It ensures that no two records are identical in terms of identification. Common examples of primary keys include customer ID numbers, employee IDs, or serial numbers. These unique identifiers allow other systems and users to locate and refer to specific records without confusion, especially when there are hundreds or thousands of entries in the table. Primary keys serve several important functions. First, they prevent duplicate entries from being added to the table. Second, they allow the system to create relationships with other tables by using these keys as reference points. Third, they ensure that each record can be retrieved quickly and accurately. Because of their importance, primary keys are frequently referenced in exam questions. You may be asked to identify the primary key in a list or choose the correct function it serves. A foreign key is a field in one table that matches the primary key in another table. This creates a link between two different tables, forming a relationship that keeps data connected. For example, a customer ID in the orders table acts as a foreign key that points back to the customer's table. This lets the system know which customer placed which order, even though the information is stored in separate tables. Foreign keys are critical to organizing large datasets and avoiding unnecessary duplication. Relationships in relational databases are formed by matching primary keys and foreign keys across tables. This structure allows the system to keep related data organized without having to store the same information repeatedly. For example, instead of storing a customer's name and address with every order, the system stores the customer's ID in the Orders table and pulls the rest of the data from the Customers table. This separation improves consistency, simplifies updates, and reduces storage needs. Linked tables are a key feature of relational databases. In practice, this means a products table might be connected to a categories table, allowing each product to be sorted or filtered by type. An orders table might include a customer ID that links to the customers table, allowing reports to show which customers made which purchases. The exam may present scenarios like these and ask you to identify the role of a key or recognize how the relationship works between tables. Relational databases offer many benefits that come from their structure. By organizing data into linked tables, they make it easier to manage, retrieve, and analyze large amounts of information. This setup supports complex queries, data validation, and scalable reporting. Because of these advantages, relational databases are widely used in enterprise applications, government systems, healthcare platforms, and many other fields where data consistency and accuracy are critical. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Fields in relational databases can store many different types of data depending on the needs of the application. The most common field types include text for names and descriptions, numbers for prices and quantities, and dates for events such as orders or birthdays. Boolean fields are also common and store simple yes or no values, often represented as true or false. To maintain clarity, each field should have a name that accurately reflects the kind of data it stores. For example, email address clearly indicates its content, while status might represent whether an account is active or inactive. One important concept related to relational database structure is normalization. While the process of normalization itself is beyond the scope of the Information Technology Fundamentals Plus exam, it is important to understand its purpose. Normalization involves organizing data into separate but related tables to reduce duplication and improve consistency. For example, instead of including a customer's full information in every order record, a normalized database places that information in the Customers table and links it using a key. This structure makes updates easier and reduces redundancy. There are several core terms you should memorize to understand relational databases and prepare for the exam. These include table, which holds the data, field, which represents a single category of information, and record, which is a complete row of related data. The primary key uniquely identifies each record, while the foreign key connects records between tables. Additional important terms include row, column, relationship, and unique. Each of these terms helps describe how data is stored, accessed, and linked. These elements may appear on the exam in various ways. You might be asked to match terms like record or field to their definitions, or to identify which component links two tables together. A description of a customer table might include fields such as name, email, and customer ID, and the question might ask which of these is most likely the primary key. Recognizing these structures in real-world examples and being able to associate each term with its function is a key skill for passing the database portion of the exam. There are also specific tasks and topics that are not included in the Information Technology Fundamentals Plus exam. You are not required to create a database, define relationships using SQL, or perform any type of database modeling. Schema design, normalization techniques, and command-line database queries are all considered outside the scope of this foundational certification. Instead, the focus is purely on recognizing the core building blocks and understanding their role in organizing and linking data. Relational databases are used widely across many types of systems. You'll find them in e-commerce websites where customer, product, and order data must be maintained separately but linked together. Inventory management systems also rely on relational databases to track stock levels across different locations. Enterprise resource planning platforms, known as ERP systems, use relational databases to manage finance, procurement, human resources, and other departments from a single structured backend. All of these applications rely on the same table, field, and key structure. To prepare for questions on the exam, it helps to study common scenario descriptions and understand what each one represents. For example, if the question asks, which field links two tables, the correct answer would be foreign key. If the scenario asks, which item ensures each entry in a table is unique, the answer is primary key. If it asks, what is a table made up of, the answer would be fields and records. These question formats appear frequently and rely on your ability to identify database components quickly and confidently. Understanding these relational database concepts also supports your future IT learning. Whether you pursue a role in system administration, data analysis, or application development, you will encounter databases regularly. Having a clear grasp of how tables, fields, and keys work will make it easier to understand how information is stored and accessed in real-world systems. It also lays the foundation for learning structured query language, often called SQL, which is the standard language used to interact with relational databases. In addition to supporting technical knowledge, this topic reinforces a broader IT literacy. Even in roles that do not involve writing queries or managing databases directly, understanding relational structure improves communication with technical teams and increases your ability to troubleshoot data-related issues. For example, if an application fails to retrieve the correct records, knowing that a missing or incorrect key might be the cause can help guide the resolution process, even if you are not the one fixing it. The organization of relational databases also teaches key principles that apply beyond databases. The idea of using unique identifiers, minimizing duplication, and linking related data appears in networking, security, and software development as well. Learning this now gives you a conceptual toolkit that you will use repeatedly throughout your IT education and career. Relational databases are not just about storage. They are a model for thinking clearly and managing information effectively. To summarize, relational databases use tables to store data, fields to categorize it, and records to group it into entries. Primary keys uniquely identify records, while foreign keys link them across tables. These structural elements allow data to be organized, accessed, and maintained with accuracy and efficiency. On the Information Technology Fundamentals Plus exam, you will be expected to recognize these terms, match them to definitions, and understand how they function in basic examples. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.